so here I'm in the first file, 00 arrays. Ruby arrays are ordered, integer indexed collections of objects. Each element in an array is associated with and referred to by an index. We'll start with this array. So here we have an array here, and we've got 3 strings sitting inside this array. And as we can see, the first index value, 0, is going to give us the first element of this array. And the second value is 1, and that will give us 1, and so on. 2 will be 2. So you access any given element by its index, and for an array that always begins at 0. And if you go past the end, you'll get back nothing. So here we try to index with 3, and we get nothing back, nil, because there aren't 3 elements. Well, there are 3 elements, but remember that index is at 0, right? So it's 0, 1, 2, right? 0, 1, 2. This is interesting. Negative indexes go backwards from the end. So negative 3 starts with 0, negative 2, negative 1, and so on. Arrays know where the elements at their indexes are. This means it is just as cheap to look up an element really deep as it is for an element right at the beginning. So here we've got a sequence of array elements, 0 to 5,000, and we are using the dot to a method to convert them. So this would be interesting if we actually whack these. And you'll see like why I've got it saying that, because if I actually ran the hash rocket and did Command R, this would explode out the value from 0 to 5,000. Right? You can't see that here because it's just like, oh my god, it's so long, right? Oh, you get the idea. Okay. Keep going. So, yeah, okay, well, 5,000. Yay, see it. 4999. Oh, that's interesting, right? I didn't say 5,000, but 4999. That's because the index started at 0, right? And we let's go like that here. And we use the triple dots, right? Okay, so here, let's kill that. Oops. Forgot to push it back. Okay. Writing backwards. Okay. Alright, so like all the numbers from 1 to 5K, right? Let's see. Let's see, I forgot what does 2A stand for. Let's go look him up. So let's see. Let's go to rubydoc.org and let's see. The first Ruby we're using is 212. What the heck? I forgot what is 2A. To array. subclass of array. Converts the receiver to an array object. Likewise, 2 underscore h is to hash, returns the resulting interpreted array as an array of key value pairs. So RubyDoc is very useful. It's sort of like the library, right? Of yes, literally, this is the documentation for everything in the language exists in RubyDoc. So yeah, rubydoc.org. We get all the different variations of Ruby. Okay, so let's see what happens if we don't have that there. Let's do that. We don't have toArray here. We'll just do the hash rocket. Nifty, just 0 to 5,000. We are assigned literally what this actually says, right? Versus here, when we do the initial assignment, we're actually saying that this is an array with these special bracket symbols here, and then putting the values inside of it. But here we're doing this this series of things that we're setting up for the array. But since we're not using an actual array symbol here, right? So what happened if we did? No. Would this craziness work? Of course not. Right? Because it just sees it as a string sitting there. But if we do A and then run it all the way to 4,999, right? Or 5,000 elements in the array, index as 0. All right, let me undo that. Start writing backwards again. And go on to the next one. Okay, so about half a second to access element at index 2500. Okay, yeah, so start time. This is pretty cool. We can use this feature. Time now, we're telling it to actually start this time right now when this particular variable is assigned, initialized. And we're saying, okay, these are many times array 2500. So time now minus start time is going to give us this exact start time when the sucker was called. And let's see, about half a second to access an element in index 0. So here we're looking for an element in the 0 index, and here we're looking for an element at index 2500. And it's pretty close. It's almost the same. So let's actually run that. I'm going to delete this and then just run it just so we can see it, because that's cool. Oops, oopsie. Now, what did you forget? You forgot to put your rockets in. There we go. Get all lined up. Yay. Oh, neat. Even closer this time. Almost identical. It's pretty cool. Okay. So 5 million times, 5 million times. So that's interesting. Dot times. Let's see. Let's look up this method. Times. So here we get times a process. Times returns a TMS structure. See process module TMS that contains user and system CPU times for this process and also for children processes. Fascinating. What's this other guy? We looked him up. We had 2 different times of process and integer. Integer times block self. Okay, so let's look how we've got it set up here. Iterates the given block integer times, passing in values from 0 to integer -1 if no block is given, and the numerator is returned instead. So that's the actual code for this advanced. Okay. All right. Anyway, a little bit more information than what's necessary, but basically, it's trying to find an element inside the array at these different locations, and we're trying to see the speed, the amount of time it takes for the result of that to happen, and it's pretty much identical. So it really doesn't matter, and that's because arrays always know where the elements at their indexes are. So it's just as cheap in time to and resources to look up an element really deep in the array versus right at the beginning, right? So very deep and right at the beginning. All right, so on to the next section. Well, the next file in our series for arrays.